What I've got here is it's kind of like the if you remember the purple cabbage turned different colors depending on the acidity. This is an actual chemical that does. It's actually a mixture of chemicals, mixture of different indicators, and it's kind of green, as you can probably see from this. And if you can't, you'll see it in a second that it's green. I'll take a little bit of this and I'll add it to plain old water. All right. Now when I add it to water, you can see that it turns the water green. Okay, not a big surprise. I put a little bit more in so you can see it better. All right. Now green, if you look on the legend, shows you different colors. It will turn red if it's acidic, blue if it's basic, and green means basically it's neutral. Okay, and you would expect water to be neutral, and that's what this is. Now, what I'm saying up here is if I add hydrochloric acid, HCl, which is right here, okay, and I add him to the base, sodium hydroxide, right? Let's watch, what do you think is going to happen? Well, let's add some acid first. If I add some acid in first, let's watch what happens. Okay. It turns it clearly red. Yellowish red, I didn't add a whole lot. It's not very acidic. It probably looks like it's about 5 or maybe 4. All right. Now, if I add some base to this, what you think is going to happen? Well, what am I going to get from that equation up there? Salt and water. Now, it's very, very difficult to do this with these droppers, but we're going to learn how to do what's called a titration, where if I could add this slowly enough, I can actually neutralize it again and turn it back to being green. Oops. I'll probably go over. I'll add a little bit too much. But if I'm adding this drop by drop, notice the color is changing a little bit. See it getting a little bit darker here, turning a little shade of purple every now and then. There we go, almost. Put a little bit more in. There, you saw that flash of green there? A little bit more. And it went too far. Okay, oh, not quite. Yeah, it came back. Okay. What's happening as this, now it's yellow. Okay, that's good. Look at that. Green. If I add this perfectly, and I get this to turn exactly green and back to neutral, what will I be dumping down the sink?
Water
and salt water, right. All right. If that's basically almost back to where it was before. It's kind of the same color green it was. By the way, if you're wondering why it's doing, let me explain. If you're like freaked out, Zach's like freaking out over there. The reason it's changing color is there's little drops of this stuck on the side. And actually, this illustrates a great point. When we are doing our titration, you know the squirt bottles we have? There's two things. One is we're going to be doing a titration. Both of them we're going to be doing them in these Erlenmeyer flasks, because notice what I could do to an Erlenmeyer flask without spilling. I could swirl it. Number two, I will have you squirt every now and then with those wash bottles with the still water and rinse the sides down. Because as you can see, whenever that stuff's splashed up here on the sides, if there was any little drop of acid or any little drop of base there, it was enough to turn it color. All right. So, but now it's pretty much back to that green that I started out with. So it's back to being neutral. So what am I dumping down the sink? I'm basically dumping salt water down the sink. All right. So that's what's called a neutralization reaction, because I take an acid and I react it with a base, and I get a neutral solution. Water is neutral, we know that, and salt is also neutral. So that's what we're going to be learning about today. How to not only do these reactions, but how to name the salts. You say, well, I know how to name salt, sodium chloride. Let's think about this for a second. Is that the only possible salt I could have? Is that the only possible base I could have? What if I use potassium hydroxide? What would I have gotten over here? Potassium chloride. Potassium chloride, believe it or not, is a salt. Is it salt? Is it the salt that we're familiar with? Is it table salt? No. But potassium chloride is classified as a salt. What if I had, instead of hydrochloric acid, I had sulfuric acid? Sulfuric acid, if you remember, is H2SO4. Think about it. The H's will still go with the OH's and make water. I have to balance it, but whatever. And what would I get over here? Na will get together with what? SO4. You know what that is? What would that be? Sodium sulfate. Sodium sulfate is a salt. anything that you get from any acid and any base reacting together is a salt and water. Okay? That's called a neutralization reaction. It's formed from a neutralization reaction. And what I was just doing up here with acids and bases in little pipettes, little disposable pipettes, you're going to do for real, measuring in a burette something called a titration, where we'll try to neutralize a solution, and for a reason. We'll have a reason behind it too. I don't want to spoil the surprise, but you'll see. Believe it or not, many of you have done titrations without even knowing it. If you have a pool or a hot tub or a jacuzzi, you probably have to do some type of titration to find out whether to add chlorine or whether to bring the pH up or down. But we'll talk about that in a couple of days. Let's just go over neutralization reactions first. Okay, what's a neutralization reaction? Well, first we have to drop some acid. Okay. Charlie Sheen, he's the man. Into this base for a neutralization reaction. That's not really what he meant, by the way. You know, it's been a couple of years, but you remember when he went like nuts? Nobody, a couple people remember that. What was the show he was on? And then they kicked him off? 2.5 Men. By the way, last episode of 2.5 Men, I believe. Or no. That's the last episode of How I Met Your Mother. That's this week, I think.
I love that show.
I'm glad you like that show. Yeah. Let's drop some acid into a base. That's really what he was talking about at the time. It's just that people misunderstood. He's a misunderstood guy, Charlie Sheen. So any acid plus any base is going to give you two things. What two things? A salt and water. Okay? And I'm going to do a whole bunch of examples as much time as we have, since we have the announcements and we have shortened periods today. I probably won't get through all of them. What time is this? Over 34? We'll get through at least a couple, though. Okay? Let's take the most common one, the one we're most familiar with. HCl plus NaOH, the one I was using as an example a minute ago anyway. Now, everybody can finish that equation. No one's going to mess that up. You're going to get a salt. Oh, sorry. I thought that was finished for me, but I guess not. You're going to get NaCl as your salt and H2O as your water. And everybody, by the way, guess what? Remember, we had reactions before. We've seen reactions before several times. We saw it in the last chapter under solutions for precipitation reactions. And I had to write the formulas, balance it, and name it. And way back when, right before Christmas, we saw reactions too, right before stoichiometry. So we saw reactions before. I always name everybody. This guy's name is hydrochloric acid. What's NaOH's name? NaOH, what is he? Sodium hydroxide. NaCl's name, what's his name? Sodium chloride. Some of you are probably looking at me saying, well, duh, this is way too easy. All right? And you're right, because I picked the three easiest things you can possibly. Your most common acid and your most common base come together to make your most common salt. Okay? But that's not all. There are literally thousands of combinations I could have here. All right? Think about it. All of the possibilities I could have for acids coming together with any of the possibilities for base, and then mix them all up. Okay? I can have hydrochloric acid react with any other base and give me a salt. Okay? Let's take a look at that. Next example. H2SO3 plus KOH. Now you may be seeing why I wanted you to learn so well. I took an extra day in the quiz. So well, I wanted you to learn those acids and bases, how to name them. Because guess what you're going to have to do in every one of these neutralization reactions? You're going to have to name an acid, and you're going to have to name a base. And you're also, on top of that, going to have to name a salt. Now, what salt am I going to name here? Let's take a look. Let's finish the equation. That's what we always did. How are we going to finish this equation? Well, let's talk about the salt first. What's going to come together to make the salt? It's pretty obvious, isn't it? We're going to take the K, right? And he's going to get together with this guy, right? That makes sense? So I'll have K and SO3. And then what else will I have?
Water.
Water. Now, some of you guys are going to say, yeah, we're going to get They're going to do this. They're going to go, okay, yeah, they're going to do this. We're going to make a brand new formula for water. Emily just said it. We're going to make it H2OH or H3O. No, we're not. What's the formula for water? Formula for water is H2O. And it's the formula for water in this problem as well. Water is formed in every neutralization reaction. So all of you are about to stop me and say, but wait a minute. That doesn't make any sense. Because now I've got too many H's over there. And yeah, what do we do in that case? We balance the equation. We don't rewrite the formula for water because we want it to be different this time. That's what you will do on the test. And what else did I not do right for this guy either? I was trying to show you all the mistakes. Did I write K and SO3 correctly? No. K's got a +1. SO3 has a -2. You know that from the common ion sheet. K2SO3. And I have to balance it. So you see how, going from that really easy problem a minute ago, sodium hydroxide and hydrochloric acid giving you salt and water. We already have a problem where we've got mistakes we're making. Now, how do I balance this guy? What do you think? Well, let's take a look. I got 2 K's. I'll put a 2 there. How many H's do I now have on the left side of the arrow? 4. So I'll need a 2 there. Is that it? Everybody good? I think it is. All right, what do I have to do now? I'm not even half done. Oh, I'm about half done. I got to write the correct formula for each of these guys. Now I'm going to shorten it up by not writing the word acid after each one. What's H2SO3? Sulfurous. Good. I'm just going to leave out the word acid just to save me a little bit of room. How about KOH? What's his name? Potassium hydroxide. K2SO3. I love this. I know. I want everyone to come up with an answer for this. I'm going to call on someone. Someone who I think doesn't know the answer. What do you think K2SO3 is probably called? What will you have to look up for that? What do you think?
It's potassium sulfite.
It's potassium sulfite. Now, I know some people were thinking, well, why isn't it potassium sulfurous? That's what it was over here, sulfurous. And that's what you're going to put on the test, guaranteed. I said back then, and I'll say it again, you make this letter any other letter, and it is sulfite. But it's sulfurous only when he's an acid, when this is an H in that polyatomic ion. That's when he's called sulfurous acid. Only time you'll use this is when you have an acid. Every other time it's the sulfate or sulfite or hypo or per-ate or hypoite. It is not going to be us for a salt. And we also know that. Okay? We know that. We've been naming salts, believe it or not, since we first learned how to name compounds. We just didn't call them salts. We called them compounds, ionic compounds. All right. What time did I say this over? 35? We got time to do one more problem.
4.
One more problem. What if I do it backwards? What if I give you the names and I ask you for the formulas? I really highly recommend, by the way, write small, because this is obviously going to take up a lot of room. I highly recommend something at this point. You know what that something is? Don't try completing the word equation first. Because here's what I'll get if you try to complete the word equation first. Oh, okay, hyponitrous acid plus aluminum hydroxide, aluminum acid plus hyponitrous hydroxide. That's exactly what people will write. Okay, it makes absolutely no sense, and when you try to write the formulas for it, you realize you can't do it. So let's write hyponitrous acid first. H, right? And what? Hyponitrous, hypo-us.
1 less.
Hypo-us is not
2
1
less.
less.
2 less.
2 less. So that'd be HNO, right? Got it?
Yeah.
Is it written correctly? +1, -1? Yep. Aluminum hydroxide. Al.
OH3.
+3. OH. -1. Good.
It yields
Now, finish it with the word with the formulas first before the words. What's my salt going to be? Al.
ALNO.
ALNO.
3.
Parentheses 3, because there's a +3 there, a -1 there. Got it.
Plus H2O.
Plus H2O every time. Oh, no, it's HOH3, isn't it?
No.
Somebody will do that. The new formula for water is HOH3. Okay. Is it balanced?
No.
No. No. Heck no. Yeah. Let's see how many we got here. Well, how many no's we have here? Well, I have 1, but how many no's are there? No, 1 nose. 3. No. No. So I need 3 here, right? Mm-hmm. All right. So I got 3 O's there, right? We can also name these guys too. Hello. Hello. That's British. He's actually aluminum hydroxide. He's British.
Did you just come up with that, or did
Hello.
you have that planned in the speech?
I have everything planned. I don't know. And now, what do I need over here to balance the rest of this out? How many hoes do I need? Well, I'm just pronouncing it phonetically. I need at least 3 hoes to make this work.
Oh my lord, this is going on.
Okay. Now you can't name it like you're in the hood. Okay, they're not really LO and hose. They are actually really things. Hyponitrous, aluminum hydroxide. What would this guy be? Aluminum. Careful. Hypo. Nitrite is correct. Don't let that 3 confuse you. If that 3 were on the inside, it would be a nitrate, right? But he's on the outside, so it's actually hyponitrite. Wow, look at that. That's pretty impressive. We already have water. You do not need, by the way, because we're going to run out of room for naming anyway, no one needs to name water. I certainly hope everyone knows the name of water for all of these. I'll give you some problems to work on tomorrow since we didn't have a full period